And here we have a demo of how to do the bonus problem this week. So the bottom of the screen shows variables from the data that our class collected over the past year. So you can see all of these students in our class chose a few people and did a survey and gathered all these data. It's the data we'll be working with. And what you're asked to do in your homework problem, you're going to be asked to find two of the variables from the bottom of the screen that you predict would have a positive relationship. In this example, I'm doing a negative relationship. And so we're going to use the 5 steps of hypothesis testing, and I'll show you how to do it. So I've listed all the variables here to make it a little bit easier. And I would be willing to predict that maybe, I didn't plan this ahead of time, which ones would correspond inversely. That maybe screen time would correspond inversely or in a negative way with, I'll paint this yellow, with hours of sleep per night. And so that's going to be my approach here. So we're going to have people like those in our sample compared with people who have no relationship between the two variables. Our X variable, I'm going to use screen time for X, and our Y variable will be hours of sleep. I'm predicting a negative direction. As one increases, the other will increase. And I'm just going to state the hypotheses in short form. Rho will be less than 0 for the research hypothesis. And rho will be equal to 0 for the null. Next, we have to get a scatter plot and then predict where the points are. And so look at how I'm going to approach this. My two variables are hours of sleep and screen time. So I'm going to go down to the data set and get hours of sleep. And I'm going to just copy it. I'm going to click in the top cell, hit Control-Shift down arrow, copy. And let's just paste that right here. And now I have to get it lined up with screen time right here. So I'm going to click there. Excuse me. I'm making this video too late at night. So I'm going to go to the down arrow, copy, and I'm going to just paste this right up front here. All right, and now I'm going to just get rid of everything else that's here. What I've done is I've just selected all the top cells and then I've used Control-Shift down arrow. So now I can just hit delete. Now I have a little bit of a clean space to work with. Now you already know how to create the scatter plot. You're going to select the top 2 rows, top cells in the columns of data you're interested in. Hold Control-Shift down arrow, and then you can go to Insert, and let's get that scatter plot. Okay. It's not looking like my prediction is going to be right so far. At least I don't think so. I can square it up a little bit, but it's looking almost like a positive relationship or no relationship at all, according to my eyeballing. So I'm going to predict that this isn't a negative relationship. This is almost looking like a positive correlation here. I'm going to drag this out of the way because we'll have to do the math in here. I'm going to hit Control X and just push this up to the top here. See if I can get this up here. There we go. So I don't know, looking at this, I would say my hypothesis is off. I'm going to say our estimate is going to be positive 0.5, maybe something like that. Next, we look up the cutoff point, the number of pairs -2. And I'm not sure that this is totally right here, so I'm going to just count them. So I'm going to do a quick little formula. I'll just throw it in someplace I don't need it. Actually, let me put it in right here. I'm going to write the number of pairs right here. equals count A, and I'll click in the top cell here, Control Shift down arrow, and let's make sure it is in fact 88. It is. And so now DF is going to be n minus 2, so that will be 86. And now we have a starting point for our problem. So let's go ahead and look up our alpha. I'll go to our calculator tool, which is not up here right now, so let me grab it. You'll know that this is already marked in our course resources. I'm just getting it from here for the sake of this being open. Remember, in this tool, we have to scroll way down. We're looking at 0.05 with 88 degrees of freedom. Let's calculate for R and scroll down again to see what it is, and it's 0.174. The correlation greater than 0.174 is going to be significant. That gets to that effect size power kind of problem that we looked at in chapter 2 in some sections of this course. And so let's go ahead and write the 0.174. Now, typically we would want to draw this out. I'm not going to do it right now, but you know what this looks like by now. Let's go ahead now and find out our sample. We'll do some math here. In order to do this, I'm going to separate these two variables so I have a little room to calculate the deviations. I'll do that by selecting it, Control Shift down arrow and copy. And I'm going to use Control X actually to cut it. And I don't know exactly how many rows I need here, but let's go ahead and paste it over here. All right, now we have some room to work. So first off, we're going to need to get some information on X on sleep. Actually, I was going to say X was screen time, so I better write it over here. It doesn't matter, actually. I think I'll do it here so I don't run into any mistakes. And I'll put screen time over here. All right, so let's go ahead. We need to find out N. We're going to need to find out our mean for X, our N for X, our sum of squares for X, our variance for X, and our standard deviation for X. So we already know that it's 88 for N. Our mean, I'm going to use the average function. You already know that you're not allowed to use the standard deviation function if you know what it is, because there are different formulas for different circumstances, and I'm not teaching about that here, and plus you have to know how to do it. So now we can get our deviation, X minus MX. Let's go ahead, get 6 minus MX. I'm going to put that $sign here. All right, here we go. Click that down. I would click that down. I don't know what's wrong. Don't know what's, there we go. And next we can get the deviations. I just put the squared symbol there. And we can click that down. And from here, we can get our sum of squares. And we can get our variance. And we can get our standard deviation, square root of the variance. And that allows us to calculate our z-scores for X. We know our formula for z is the deviation minus, divided by the standard deviation. So we can just click in the deviation cell, and we can divide by the standard deviation. We'll need to put the $sign in here, of course, so it will migrate downwards. And let's double click to get that calculated. And it looks like I bumped this too far over, so I'm going to Control Shift down arrow, Control X, and I'm going to push it right here. And there we go. Now we can go ahead and do the same for our Y variable. So we're going to need to have N for Y, M for Y, the sum of squares for y, the variance for y, and the standard deviation for y. So we can go ahead and get n. We already know it's 88. We'll use our average function. I'm working through this quickly because you will have done this quite a few times already by the time you get here. Let's do y minus the mean for y. Making sure to put the $sign in. And I'm going to do all this at once here. Let's square it. And we can even get the z-score here. Deviation. Whoops, we can't do that quite yet. Let's go ahead first and calculate our sum of squares. Equals the sum of squared deviations, which we have to hold off on because I haven't copied this down yet. So I'll select both of these and click on that magic square in the lower corner. And now we'll be able to get our sum of squares. Clicking in the top cell, Control-Shift down arrow and enter. Let's get the variance. Taking sum of squares divided by n. And the standard deviation. Square root of the variance. Our z-scores we can calculate now is the deviation divided by the standard deviation. We'll get the $sign in there so that we can use this as a copy paste. Aren't you glad you don't have to do all this by hand? Now we have our zx, zy. So let's go ahead and get the sum of cross products. Zx, zy. That's what our cross product is. So let's go ahead and take Cx times Zy. There we go. We can, I don't think it's going to work our magic way here because I've got that little column in the middle there. So we have to do it manually there. I just did a copy paste function like the old way. And now we just get the average of that. We have to take the sum of all those cross products and divide by n. So let's go ahead and get the sum of cross products. We could also say the sum of zx, zy. We could do this all in one step if we wanted to. There's our sum. And we can divide by n. Let's put our Pearson R. We come up with a 0.13. Really nothing going on here, even though we have such a low cutoff point. Our R sample equals 0.13. My decision has to be to fail to reject because 0.13 is actually on the inside of the distribution. And our conclusion has to be there is not a significant relationship between screen time and sleep hours for people in our sample. And we'll put R86 equals 0.13 ns. And because it's not significant, we don't have to fill in these explanations. And that's the end of that problem.